morning and welcome to this lecture on multi-track modular teaching for research-oriented teaching. Okay. Now, I'm very thankful to Amity for having invited me. I know Amity is one of the largest universities in India. It's also one of the universities which uses a lot of new, innovative methods to enhance the research teaching as well as academic performance. So I just want to focus on this research-oriented teaching because it is one of the most important element for many of the deemed universities in India today. So this is actually a survey conducted by National Employability on Employability in 2019. So they found that a very small percentage of engineers are employable in some of the most emerging areas such as software jobs and so on. And new generation skills such as AI, machine learning, data engineering also is not available to meet the demand. Okay. In fact, if you consider US versus India, US has about 4 times more engineers with the good programming skills compared to India. So despite India being the 3.5 times bigger in terms of population. So you can see the disparity in terms of skill sets available. In fact, a much larger percentage of students, particularly among the engineering graduates of various disciplines from ECE to mechanical or civil engineering, cannot write error-free codes even as compared to China. This is an improvement that China has made in the recent times in comparison to India. So in fact, even the project-related work or the internship-related work beyond the usual coursework, that is actually lacking in Indian universities. Okay, so most of the Indian universities, I do not say every Indian university, but if you see the pyramid of Indian universities, among the top universities as well as the middle tier universities, and if you see the significantly larger number of academic institutions, either colleges or universities or whatever, the percentage of students doing projects, hands-on tasks, internship is actually much less. So that is what is actually less than 50%. So there are many new areas where we need to actually improve. So I just want to quote a few numbers from a recent NIRF ranking just to highlight how important is this particular topic is. So this is actually NIRF 2021 ranking. You must have already heard that, but if you haven't heard, this is a very useful piece of information. So if you look at engineering alone, so the number of research publications that is coming out in the world is something like 2.9 million papers. Okay, and in India we generated something like 199 lakh, so 1.9 million, 1,99,000. Sorry. 1,99,000. This is actually about 6 to 7% of the total publications that come out. Okay, now this is significantly less in comparison to the Indian population. So if we consider research publications as one of the outcomes of innovation or one of the outcomes of the intellectual property, then we are actually behind. Okay, in all these numbers you can see now another number which is actually the very frightening number, number of institutions having 0 publications according to NIRF. NIRF may not have full number, but there are large number of institutions without having any publications at all during the reporting period of NIRF 2021 ranking. Okay, so this is actually very significant as these institutions which actually serve a large number of populations do not actually have any research outcome from them. And again, this is from the NIRF ranking, which shows the correlation matrix between research performance. The x-axis here is actually research performance, and y-axis is actually NIRF ranking. If NIRF ranking is actually a metric of some sort of research performance or some sort of quality of education, then this is actually almost 0.69 here between general ranking as well as research performance, and university ranking 0.63 is a correlation index or coefficient. So this is for engineering, this is about 7.78. So there is a very close relationship between research output and so on. Okay. And ranking, just in NARF ranking, I'm not saying NARF ranking is the best metric of performance, but some metric of performance, if you use, this is how the relationship is. Okay. Now, second aspect, which again is most recently quoted in 2021, is the number of faculty with the PhDs, which is about 39.31 compared to the master's degrees, where the rest of the faculty, which is something like 61% is a master's degree. There is significant improvement over the past several years that India has done in terms of this particular thing. Okay, now I just want to highlight one another aspect, which is again an eye opener, is the disparity of research in India. Okay, the disparity of research is with respect to the top institutions versus the rest. Okay, so if you see the publications of the top 100 institutions, let me take the engineering alone as an example, or we can take any number, any category here. Okay, so out of the 174,000 publications, 119 actually belong to the top 100 institutions. Okay, India is a very, very large country with several thousands of institutions, and we get only less than a third from the rest of the institution. So which means 68% is actually belonging to the top 100 institutions. So this is actually because of the disparity, as I mentioned earlier. If you have the institution pyramid, the top 100 is somewhere here, and significant output is actually from here, and much less output comes from the vast majority of the other institutions. So in fact, this is from the empirical law of Bradford, which is applied on the Indian research scenario, where when you consider the four quartile, where most productive versus medium productive, low productive, or least productive, and the university with the zero output. So current Indian situation for research outcome in terms of publications is actually here. Okay, so you have about 13 universities or institutions that produce a significant amount of research publications, and the rest of the significant quartile is actually produced by 31 institutions, and then the third low productive is about 78 institutes. So you can see the graph where the least productive number is very significant, about 700 plus, if you consider a limited number of Indian institutions. Okay, so our objective is to actually enhance the performance of the institutions within the medium as well as bottom of the pyramid. It is very, very important, because if you consider the India's performance, the top tier performance is not enough or not sufficient or not going to make any serious impact in the average quality of life enhancement of India. So we actually need to consider the other university systems also if you want to really work on this. This is actually done, it is taken care of. There is very high funding, very high quality faculty, very high quality students on performance is actually on par in terms of publications, prototypes, industry outreach, and so on with the rest of the world's best universities. But that is not how the rest. So we need to work here, work needed here. And if you consider the world scenario, some of the world's best universities such as CMU, MIT, Harvard, all private universities. Okay, that kind of a leadership role in terms of research and impact is not happening in India in the private university system. Okay, in India, government universities are very highly ranked compared to private or deemed universities. In fact, if you consider the situation at the kindergarten to +2, private schools actually significantly outperform compared to government schools. Okay, the private sector had taken over in this particular segment. You will pay very high fee and you will send your children to a private school than a government school. The government system is actually underfunded, undercared, and with very low resources there. I'm not saying it is actually a good thing, but I'm just bringing the comparison between the school system versus the university system in India. On an average, private schools do better teaching, better performance, better training of students, and so on. But when it comes to higher studies, government sector is actually doing very well. So why Indian private universities are not becoming top ranked ones? How Indian deemed universities can be developed to a better level? How can teaching and research be improved in deemed universities? How can we make an impact? And this impact can be in many dimensions. Employment is one, no, prototypes and patents are another. Intellectual copyrights like copyrights, publications, or even industrial consultants. There are many dimensions of impact you can actually find in this, but impact in all these dimensions are very important for deemed universities. So finally, how can teachers derive research benefit? Okay, this is very important because as a teacher, we teach a lot of courses and we correct papers and we evaluate and we graduate students. At the end of the life, the number of students we taught is actually the outcome that we do. Okay, in addition to doing that, we can also get research benefit from teaching. So that is what where the method called the MT2 that can actually be of help. Okay, now I just want to briefly touch upon this Bloom's taxonomy that you all very well aware of that, I'm very sure. So the point is how to apply this Bloom's taxonomy through this MT2. That's what. So this is actually a very old concept. So you use this Bloom's taxonomy in today's IIST based outcome based education or GSA based regulations to design curriculum, to give examination questions to match various cognitive levels, and also to have some sort of structure in the assessment based on the target level that you actually do. So basically, the Bloom's taxonomy defines 6 levels of competencies based on the cognitive effort required or cognitive capability required. So these 6 levels from memory or basic capability of remembering to creating, remembering, understanding, applying, analyzing, evaluating, and creating. So the cognitive workload increases. This is a popular representation that IIST is actually giving about the Bloom's taxonomy. So if we ask questions that will actually enable students to remember facts and figures, that is a cognitive level which is of not as high and as contributory as the level that we expect from the level where students can create things, new things. Okay, so you are also maybe aware of what kind of questions or verbs or cues that can be used to create examination questions that you will be positioning your question paper to various levels, like remembering. For understanding, you have to ask these terminologies. These are examples. So as a teacher, you may be able to modify that according to your requirements. Okay, now with various levels. So these are all there in ACT documentation. So but what is actually the problem in our classrooms? Why our students, as I have earlier mentioned, a very low employability situation? Why our students are not becoming very creative as much as teachers like us we wanted? Okay, so some of my opinion. Okay, these are all my opinion. Everybody has their own opinion, and one thing that I observed is that the monotony of lectures or teachers actually. Many classrooms, the teachers actually give a monologue. The passion for the subject is probably not there. And in many institutions, I am not saying any particular, in many colleges, I have observed that the teaching subject is actually forced on a teacher by the management because of financial constraints or because of other constraints like human resource constraints and so on. I have observed, physically observed in some of the colleges where subject on refrigeration was taught by electrical engineering faculty. faculty who have not having any kind of familiarity with that, or an electronics faculty teaching a subject on electrical engineering. While electronics faculty is much better at his subject, but he is a poor teacher in an electrical subject, or a computer science faculty teaching electronics, and so on. So these are all constraints that many of the academic managements face today. As a result, they have to force some teachers on some subject. As a result, you have a very poor outcome in the academic classrooms. So all these are actually accounted for lack of resources, either financial resources or human resources or other kind of resources. Okay, so this is one aspect that we face in across the colleges of India. Teachers, those who are really passionate, those who are really expert in subjects, they face new challenges. Okay, every one of you will be facing, and you may be good at describing many more challenges like that. One of the biggest competition that we face today is like the web resources. Okay, YouTube is one of the biggest resource that is challenging a teacher in his own subject, in the area where the teacher has been working for several decades, with a new way of explaining, new examples, new kind of video or animation or whatever. So NPTEL courses, for every subject that you teach, there is an NPTEL course. Coursera, edX, and other kind of MOOC websites are actually offering very significant challenges to teachers. Okay, now mobile phones, students actually use the mobile phones in the classroom, outside the classroom, and everywhere, and they find an answer to query through the mobile phone, not through a teacher. So the dependency on the teacher is less now, and sometimes soon after a teacher clarifies a question, students use mobile phones to find the answer is slightly deviating from what the teacher was able to recollect from his mind, and so on. Then the third challenge is like faculty feedback. Faculty feedback is something that is threatening every teacher for his existence, because the feedback is poor, that can affect his employment, his or her employment. The feedback is actually, so you may have to reduce the pressure on the teacher. You may have to reduce assignments on students. So the faculty feedback may be better, and so on. So while how to have a balance between assignment, number of hours of workload that you enforce on a student versus getting a good feedback, that is very big challenge that teachers face today. I don't have an answer to that, but I'm just listing the challenges that new generation teachers are facing, people like us. Then students can actually mention the performance of the teacher in social media, which was not a challenge until several years, until maybe until the social media's emergence. But today that is actually very big. So every word that a teacher speaks or instructs is actually made with extreme care in many teachers' cases, because they don't want to get a negative feedback from a student in a social media, which can affect the reputation of the student. Okay, so the only way, in fact, all these challenges are offering constraints and difficulties and challenges. The only way to overcome this is, as former President APJ Abdul Kalam mentioned, that to fly above all. Fly above all. So his example was that all birds find shelter during a rain, but an eagle avoids rain by flying above the clouds. Okay, all these challenges are actually clouds. You have to fly above these challenges, and you can overcome that. So which means that you use all the above resources available to the students and benefit from such resources, so you will be able to fly above. So for the topic you are going to teach, you look at a web search. And for the topic, you just glance through YouTube videos and see what way they are representing. If, out of like 5-10 examples, one example suits better you take that example and do that. Or look at what way the NPTEL videos teach a specific topic that you are teaching. So when you use these materials to update yourself, you are actually going to be using this fly above troubles method, so which will actually be very important. Okay, now why these new teaching methods are important? So one of the best way to capture that point is this Chinese proverb, which says, you tell me I forget, show me I remember, involve me I understand. So this is like you have to use multimodal teaching. Okay, multimodal teaching is nothing but a teaching method or any kind of teaching method that use multiple modalities. Okay, not only the instructions in the class, not only the examinations at the end of the course, but use different modalities. So you can get the students to be involved by using this multimodal. This is a very, very careful activity which has to be applied in a very strategic manner without even the students realizing this. Okay, so because we can do this multimodal teaching, we can actually create creators and not just people who graduate from an institution. So I will have several examples, but I don't want to highlight all of them. But one particular example which you can actually see about this MIT professor, Walter Lewin. You must have already seen he is also a controversial professor much later in his career. And one such controversy, racial word that he uttered had made him retire also. He is now retired professor. So he's one of the best examples of a teacher who actually clears the fundamentals in the classroom. So this is actually where he teaches, where he taught physics. Okay, this is actually a a pendulum. He's holding the pendulum in this is a classroom actually, and he constructed a pendulum to show and demonstrate the principles of physics. Actually, this is where he is actually sitting on the pendulum. Pendulum is actually here, and he's sitting on the pendulum is actually moving around or swinging around to see the pendulum is actually moving, and he is also moving here to measure the frequency, to measure the period, time period, and derive the equation of the time period as well as the frequency relationship or many other characteristics related to pendulum. Okay, this is one of the classes. This is a YouTube snapshot. You will be able to find this YouTube video as well as several of his physics lectures to do how he is teaching. So one important thing is that for 1 hour lecture, okay, 1 hour of lecture, okay, he spends several hours of preparation, several hours of preparation. This is very important. Many institutions do not allow the teachers to prepare well for a class. Okay, so I want to tell you this particular number that we used in UC San Diego to estimate the workload of teachers in the research universities. Okay, so if you are teaching 2 new courses, okay, 2 new courses, which means each course take 50% of your time. So that is full workload for you. Okay, 2 new courses, which means 8 hours per day of effort. Okay, is actually consumed if you are taking 2 new courses. So this is the estimate of work required for a course. Okay, if you are teaching 3 old courses, which means old courses are courses that you have already taught once, which means you are taking a second time or third time, then this is about 33.3% into 3. You will be able to take 100% of your effort. If you are a research faculty, you will be teaching something like 2 courses, old, okay, plus 33% research time. Okay. This is actually very important. I just want to mention because many of the engineering colleges do not allow the faculty members to spend sufficient amount of time to prepare for the courses, because I've seen some colleges, they are asking 6 courses for a faculty. A faculty member teaches from day in and day out, from 9 to the night, late night, and so on. And the whole life is prepared. Whole life is spent on teaching, but there is no time for preparation. That is the point here. So unless you have significant amount of preparation time, you cannot do a good class. And this is actually not really understood by many of the academic administrators. Okay, a good quality university must follow practices that are adopted in many top-ranked universities. Otherwise, university will never grow. So I'm trying to bring out this multi-modality to classrooms, and according to me, there are 2 possible methods. One is integrated multimodal teaching. Second is multi-track modular teaching. Okay, so what is integrated multimodal teaching? So this is nothing but integrating different modalities of teaching in a class or in a subject in the classrooms. Okay, which means lectures, experiments, discussions, videos, etc. can be included as part of your classes. Okay, so this is very important to get your students interested in your class. Okay, your class will be liked by the students because they are not really afraid because they are getting some sort of participation in your class. Okay, and in fact, it is very important to get them surprised. Surprise is not by running a surprise quiz. Okay, there are teachers who run a surprise quiz, surprise punishment by which they surprise a student. This is actually not making them surprised by surprise punishment, but make them surprised about the topic that you teach. Okay, which means you may have to bring up a story and suddenly introduce the scientific topic or engineering topic into that, so they will get surprised how a normal living person is connected with the engineering topic that you are teaching today. Okay, so that way they will get surprised, and this is in fact I would say I would consider this is a job of an actor. Many established teachers are also actors. Okay, actors in the sense they give a performance in the class which you cherish just like you are watching a movie, and they don't feel like they are studying or something. So this is something like you are actually giving a movie performance in classroom. So they will be excited to come to the next class. Okay, so it's very important to have this particular element of trying to do a better class than the other teachers. Okay, so because your respect is compared against other teachers by a student. The students will evaluate out of the 10 teachers, which teacher is actually standing out as a very good teacher, an excellent teacher, or an innovative teacher, and they will remember only you. In fact, I remember only a very small number of teachers from all my classes, and only if you do better than the other teachers through innovative teaching, students will remember you, and that is the only reward at the end of your life that you may get. So, in fact, good that you attended, as you may have an intention to become a great teacher through this. So let me give an example of an integrated multimodal teaching class. Okay, so you have several lectures laid out. In fact, some of the universities teachers have planned the entire course from lecture 1 through lecture 40 or 50 or whatever. Usually it will not go more than 35 or something for a semester long course, but it depends on the teacher and the university. Some universities will have 60, 70 lectures, which is actually not a good idea. Now, introduction, lecture 1, lecture 2, lecture 3.6, and in between the lecture, the teacher will be introducing an experiment related to the topic. Okay, so this may be done in the class, or this may be done outside the class, or wherever it is, but it's actually part of a lecture. Okay, and lecture means students are expecting the teacher to come and deliver a lecture, but teacher is coming and doing an experiment. This is a surprise, and at the end of the experiment, they actually learn a topic relevant for the lecture too. So that time they realize that not every lecture is comprising of 50 minutes or 1 hour of teacher talking to you, but some other activities too. Then it is possible that you can introduce a discussion session. So in this discussion session, this is an open media where you can bring out topics, you can allow students to talk. Students are not really willing to talk because they are afraid. They are inherently afraid because of the past several generations of our own upbringing. We have this difficulty in talking or participating in discussions or sharing the ideas in a class. Okay. So maybe you will bring a multimedia presentation. Today there is a lot of multimedia content that is available about any topic that you teach, and especially if you are doing a non-CS, non-ECE subject like mechanical engineering or electrical engineering, you have enormous amount of multimedia content. So you can bring some of the topics together in a multimedia session, and that day there is no lecture. You are actually introducing a kind of multiple videos to discuss. So this is actually going to add value to the teaching session, or maybe one specific topic. So you want to bring, say for example, web technologies, Web3 technologies to your classroom, and that day you are explaining Web3 technologies not by your own lectures, by the brief collections of others' lectures. So this is actually going to complement your lecture, not only the covering the topic, but also giving a different way of entertaining the students. Okay, I'm using the word entertainment because the best classes are the most entertaining classes. Okay, so again, experiments, and sometimes you may do as part of the class an outdoor visit and discuss about the topic, and thereby you class. So you are introducing multiple modalities within a course in different ways. So this difference is very important. If we have only experiment, then that again reduces the the value of multimodality. So in fact, if you are a very experienced teacher, then you can actually use this multiple modalities within each lecture. Maybe, for example, 30 minutes of lecture. Okay, so you are giving explaining some theory, deriving an equation, dictating some topics, and showing a short video for 5 minutes. And this short video 5 minutes come as a surprise to the students. Okay, this is something like students are explaining, taking notes and so on. Suddenly the teacher magically brings out something and changes the topic, and shows a different media which is complementary or an example of the topic that is under discussion. Okay, so again, no, teacher stops. Teacher is not like switching that, and he or she brings lectures back again to the table. Okay, some aspect of the continuation of the derivation or writing on the board, and a few minutes of discussion. Okay, so if you can do a small experiment in the lab, programming experiment or hardware experiment or anything, that actually brings real excitement in the class, and students will like your class better. Next week they will see all students will be present without yourself forcing them to come. So you can custom modify your class sequence based on your expertise. So it's very important that if you do this, the teacher's expertise also can be developed. Teacher will also become a better teacher when you practice it. Okay. Now, in fact, I have already mentioned here, if you are very familiar with that, if you are an expert in the topic, then you will be able to integrate the sessions within a single lecture and across several lectures. Lecture 1 through 40, several lectures will have this integrated multi-tracking content within the lecture itself or across lectures after several lectures. So the both ways you can actually practice this IMT. IMT is very good for basic courses, particularly the first year courses where you actually don't need the depth, very essential. Topics like electrical engineering, basic electrical engineering, basic electronics engineering, or language courses. You remember, language courses actually teach a very complicated skill, which is appearing to be very simple. But language skills are very challenging. It will take many years before one can actually master language skills. So for language skills, knowingly or unknowingly, all teachers actually use integrated multi-modular teaching only. Without that, language skill will not be developed at all. Okay, so that's a very good example of multimodal thing. But I want to talk to you about multi-track modular teaching. Okay, multi-track modular teaching. That's what is actually abbreviated as MT2. Okay, so this is an innovative teaching methodology where an academic course is divided into multiple parallel tracks. Okay, and each track consists of a modular set of activities. Okay, so this method can actually enhance students' interest, engagement, as well as learning. And it's easy to introduce in Indian academic curriculum because of the way how the course is structured. So let me just get into the details of that. So the multi-track modular teaching has two aspects. One is multiple tracks. Second is modularity within the tracks. Okay, so you define a course with a small number of parallel tracks. Okay, and this runs concurrently from beginning till end of the course. Each track should be complementing the other. Okay, we should not have two tracks having the same activity. Okay, so if the track one is doing one thing, track two should not repeat that. Track two can be another thing that can be complementing that. So tracks shall be identified based on the need for skills. What do you expect the students to develop? Based on that, we can define the track. Okay, it's very, very important that they track diversity, which means different types of tracks should be considered based on the topic. Okay, which you can have core tracks as well as optional tracks. Optional tracks need not be done by every student or selected students can be done. Maybe for the honor course or maybe for an extra certificate from the teacher, students can be asked to do the optional tracks. And within each track, several adaptive modules can be there. These are not lecture modules, these are activity modules. So you can provide flexibility for students to choose modules. And you can also have challenge modules, which can be very, research oriented, very, complicated that they cannot easily deliver that. So by having this course defined in multiple tracks and modularity within the tracks, you can actually bring many benefits, including enhancements and so on. This is an example. So I just show this track one here. This is one track where you handle the lectures. Okay. You may have different modules already defined as per this syllabus, like module 1, module 2, module N, and so on, depending on the kind of syllabus or curriculum you have. And you may have track 2 for one specific activity. Maybe this activity in this track is data set collection, maybe a particular data set collection, GIS data set collection, or ML data set collection, or whatever. So this track will have different modules. So module 1 of this track will define certain kind of data set collection. Module 2 may have a different kind of data set that comes, or pre-processing of the data set and so on. Module K will be to help them to create their own data sets and so on. So these modules should have a sequence of difficulty levels, so they will be acquiring the skills in increasing manner. And maybe there is a separate track activity 2, which is about conducting experiments. Okay, so these tracks again will have multiple modules. So this is actually doing a small experiment, experiment 1, experiment 2, and experiment 3 too. Okay, so this is actually this course. If you have tracks like this track, the course student who is taking these tracks will have two kinds of significant skills that will be developed. One, data set related. Second, experiment related. Okay, so that way, in addition to the theoretical topics that you cover, you actually train the student with a certain very, very important skills. So I'll show you some of the examples in computer networking where I used to conduct classes. This is actually an example that I used in 2012, where the track 1 was actually for conducting lectures, where as per the syllabus, we went from the introduction to various layers of the syllabus. So this is the modules in the syllabus of that track 1. And track 2 have been designed to improve the skills of delivering seminars. So we have identified several review papers from IEEE or ACM digital libraries, and asked the students to prepare a seminar presentation and revise it several levels and present a seminar in the class. So this was actually the track 2 at that time I have defined. And track 3 was actually to build a wireless mesh network test bed. So we have formed teams of students to develop a router, is one of the elements. And then the second module was to install the router, install the routing protocols and other protocols within your router. And that's the second module. Third module was actually to build a network test bed. And fourth module was to deploy the test bed in campus. Okay, so you can see that the seminar is actually complementing the theoretical lectures that I considered, and track 3 with building a network test bed actually helped them to study how practically they can apply the principles that they learned in the course. in 2014, there are different types of tracks. I tried lecture one, track one consists of the similar type of lectures, and track two, I have asked the students to prepare write-up, okay, by collecting several papers from IEEE and prepare a literature survey document, revise it sufficiently well, and submit the report of the survey at the end of the course. And track 3 was to build a test bed. So again, the same principle like forming teams, installing or building a router and installing the routing protocols, and building a test bed in the lab and then deploying that. That was track 3. And track 4 was to actually conduct research activity, to develop a theory, conduct a simulation study, create a new protocol, or do something novel and gather results from the study and evaluate the results. And then optional activity of translating that into publications or patents. So that is how 4 tracks were conducted. In fact, subsequently, in 2016, a different way I have tried where lecture was in track 1 and track 2 was enhanced with the research paper write-up, and track 3 was building a system prototype. Okay, this was actually a project called Micronet. We have defined this is a large project, a funded project. So the project, if the project is actually many having a large system with several nodes, so I have split that into different modules, 4 or 5 modules, and each module was actually given to team 1, team 2, 3, 4, and 5. Several teams were formed, and each team was asked to give one module out of the whole project, and each team was actually supposed to be developing a router, building a network test bed. In fact, this was part of the module which was to be completed by the quiz 1 time, implementing the test bed that was to be completed by quiz 2 time, and deploying and testing the network by the end of the final exam time. So that way, the whole project idea was implemented by different research, different teams of the course as part of this track. And many times, students, when their students develop, they will make mistakes in not only the development, but also in documenting the ideas that they had developed. Okay, this is a major problem. And in fact, this is also connected to the employability issue. They might do something, but they do not know what they do. They do not note down what they do. They do not document what they are doing and things like that. So because this was part of a research project, I had defined a track 4, which is to document the activities of track 3. Okay, so this is very important. I could have actually asked them to prepare documentation as part of this track 3. But when you do that kind of thing, combining the activities within the track, it is possible that they will underestimate the responsibility and they will not deliver on that. So how do you make them to do documentation clearly? How do you make them realize that documentation is important and develop skills on documentation too? So documentation skills, one of the very, very important skills if you want a research student or any student to do some meaningful work for you. Okay. Now, as a result, for everything that is developed in track 3, I had a module defined for track 4. So if the router is developed, if Fisher mesh router is developed, then the router configuration is actually the documentation that is to be delivered as part of the module 1 of track 4. Then when they are actually developing a test bed, then corresponding module to get the results from the test bed and find the observations is actually a deliverable in track 4 module 2. So similarly, when they implement the full test bed, there was a deliverable in the documentation track 2. So submit final documentation as part of the report. So that way, by making this track, by having this track, I have communicated to them that documentation is a very important skill required, and documentation has to be done in a very clear manner, and there are deliverables for documentation too, and as a result they are able to meet this. So if I had not introduced this as a separate track, maybe we would not have communicated that very effectively to the students. Students also would not have realized that that's an action item and they must have avoided delivering that. So That way, by defining proper tracks, you will be able to tell students what are the important skills they expect to develop as part of your course. So I have also done several experiments with it. I want to share that. So when you have a track-based versus non-tracked system, what is the difference? Okay, for example, there are certain skill areas that are very important, okay, which you anticipate that your research students should develop. If you do a non-track based system where many activities are mixed together, that can result in ambiguity and lack of clarity, and therefore there will not be delivery. And in fact, if you expect them to learn, they will actually not learn that particular skill, and you are actually going to be affected when you are employing them or when somebody else is employing them. Okay, so that way. Uh, 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 Defining the tracks is very, very important. Say, for example, if you have a track in an example course, you have track one, you have lectures, and if you are actually expecting students to get real experience with the database like Bhuvan is actually a database developed or geoinformatics database developed by ISRO for entire government of India. And in fact, it is a huge set of data which is much less tapped. And imagine that you are developing students to have a skill in using that. So in that case, you can define a track, asset mapping and data analysis. So you may define the modules based on what exactly the sequence of activities that you need the students to do. Say asset maps and identification, data analysis using Bhuvan, specific asset mapping experiments too. So as a result of doing this, you knocked down a larger problem into small problems in terms of module 1, 2, and module 3. So students will be able to easily crack each module independently. So essentially, they will deliver the objectives of track 2, either the objectives in terms of learning by them, or the objectives in terms of an R&D project for you, or objectives in terms of research activities that you intend by the students to carry out. In fact, if you want yet another skill, if your target objective is to actually develop a Bhuvan better, okay, this is to get students to learn Bhuvan, or Bhuvan database has to be enhanced. So you can actually get to the students to do modules that will be focusing on crowdsourcing for Bhuvan. So basically studying the interfaces of Bhuvan, this is in fact example module for that, crowdsourcing and geolocation coding of Bhuvan, and crowdsource the data update. So by defining appropriate modules, you will be able to create value in enhancing Bhuvan geoinformatics database. Okay. Now, in fact, you can create multiple types of tracks depending on what exactly you need to get that. So in one of my current or recent courses on computer networks had a specific, okay, specific complementary video track. Okay, this is actually video track. In fact, the video track is actually shown here. In addition to having a track one with lectures and track 2 where I'm giving assignments for them, and track 3 where I ask the students to do a literature survey, and track 4 is only for watching videos. Okay, so I have defined this watching videos as a method to get the expertise of the best teachers of the world to my classroom. So this is my classroom. Imagine that this is my classroom. Okay. And I want, the experts from world's best universities, MIT, Stanford, and, many other universities. To benefit my class, I created this video track. Okay. What I do, I take specific lectures of complementary nature to my lectures to be watched by my students. Okay. So when I do that, I avoid two things. One, I avoid the criticism that other teachers are better than me, because I'm asking my students to watch them as a complementary method to do that. Okay. And second, my students do better complementary learning too. So a point I may miss may be obtained by them. By listing and selecting this video sequence, I'm actually driving a point in deciding what kind of complementary knowledge they should get. Okay. So that is very important to decide what sequence of videos what kind of experts, what level of lectures, that should be displayed as part of the video. I select and post then their teaching learning system, so they will be able to watch it. In fact, sometimes I also ask them, I will ask 1 mark question in quiz 1 from this video, okay, or 4 marks in NSUM in the finals from this track. So I observed that students find it extremely difficult to handle the work in this video track because they have to watch videos. I have not given many videos. Actually, I have given like 5 or 6 videos, but each video is something like an hour. But the questions that can come from this video, even if it's like 1 mark, will require them to watch the video for several times. Then only they will be able to answer the questions. And while this is complementary, this can also be loading students if you do this kind of track. But it's a very, very informative track. If you don't ask marker, then students will take it lightly and they will enjoy that. So that way, having this track is actually big value addition for a teacher. In fact, as I find it. Now, when do you define a new track? When an instructor feels that a specific direction of learning is important. So this specific direction of learning is your choice. You want to decide your data analysis students need certain skill. Your IoT students need a separate skill, or your communication system students need a specific skill. That skill requirement that you intend for your students is actually the foundation for the definition of a new track. Say for a GIS clerk, you may want to define a certain type, and I'm taking the examples of geoinformatics systems, which has computer science, image processing, and so on, data analysis, and so on. So you can decide whether you want 2 tracks or 3 tracks. And if you want 2 tracks, you will probably do experiments in addition to lectures, maybe experimentation and projects on Bhuvan 2D database. Okay, so but now you think, no, last year I did 2D. I just want to do 3D this year because I want to also expand my own knowledge base as a teacher. Also, I want to advance the class, learning outcome. So you will probably introduce the next year a track 3 where track 2 activities of 2D will be converted to 3D also. Say 2D to 3D conversion of the experiments will be done too. So that way you have expanded, you have enhanced your skill, but also students also enhance the new skill. So the identifying a new track depends on what is a specific direction of learning that is required. Having a third track, which can be a light track or heavy track, can be beneficial in adding a different skill. You decide what modules are required. If you have only 1 module, that track is light. If you have several modules, the track is actually important. So how many tracks will you create and how much credit you will assign to the track? Okay, so it's very important to have a feasible number of tracks that you should do. A small number of tracks you should do. Okay, because if you have a large number of tracks, that can become very cumbersome for the teacher to handle, and it can be heavy for the instructor. Okay, for an X credit course, okay, X credit quarter or semester course, you can probably have up to X+1 track. Okay, for example, if you have a 3 credit course, you don't have to go more than 4 tracks, okay, because managing the tracks is an effort. So if it is minimal and small and handleable by you, should not have. An X credit semester course can have, this is a quarter course actually, and X credit semester course can have X+2 tracks. That is easy. From my own experiments, I am finding that. And the number of credits that you assign, you can have in a 4 credit senior undergraduate elective or PG core course, you can actually assign 1 credit for an important track. 1 credit is a workload that is something equal to something like 10 to 15 lecture hours. Okay, lecture hours. Some lecture hours are 15 minutes, some lecture hours are 1 hour, but roughly it's effort worth 10 to 15 lecture hours. And if it's an important track, if it's an important skill that you require students to get, then you can assign 1 credit to that. In a 3 credit course, you can have certain points or marks. You can actually give, I give certain points or marks for the track, so they will be able to get, some of the tracks, my tracks are 20% of the total marks. Okay, it's an important one. In some other cases, I actually give 10% to for a particular track of the overall credits, depending upon the institute rules and the instructor's plans. Okay, now I have mentioned earlier that within the track you have certain modules. Okay, so in fact, lecture track, which is typically the track 1, can also have modularity, but as defined by your curriculum. So the activity tracks, that are tracks 2 to N in a multi-track system, you can have various modules where each module should have some specific activities suggested, and these activities should have some sequence within the track, but it should be complementary to other tracks modules. So the benefit of modularity is that based on the learning ability, you can adaptively add or delete the modules. So this is very important, that if you think students are learning better and they are delivering on, you can actually increase the complexity. You can add additional tasks to the modules, and you may introduce optional modules for fast learners, while others may take the mandatory modules and so on. So in fact, one of the elements of gifted and talented education, this kind of system is not very popular in India, but in the olden days, where we have seen students getting double promotion because they are very quick in learning. And in US and other countries, they have a system called gifted and talented education. At a very early age, they identify a set of students. They will be given a special school system to advance their education. So that is very, very good. And the key element of this gifted and talented education is that the system allows students to learn at their pace. Okay. So the reason is that some of the gifted and talented students are very fast and some others are very slow. So both these are actually part of the gifted and talented system. It's not that always fast learners are actually good. In fact, they for measuring this ability of a student, they actually use the typical IQ test, and they identify. And some of the high IQ students are actually slow students too, and they are allowed to take at their own pace. So I have seen in gifted and talented system in the US, you have 20 students in a class. Okay, 20 students, and for every student, teacher defines a different curriculum. Maybe first student, the curriculum may be very vast. It is possible that second students may not have that kind of. Third student, a different one. It is possible that the curriculum of few other students will be very little. So this is the whole class, but every student has a different kind of curriculum, custom designed for a personal basis by the teacher. So the class strength is set to so low, so the teacher is able to handle the talented classroom. Okay, so that's not a problem. It's actually good, and you have the ability to adapt to the modules within the activity tracks flexibly based on how the class is performing and how the different levels of students are performing. Because the main point in the gifted and talented education is that some students are very good. They can take more work and they will be given more work. Some students are thinking very differently, very creatively. They will not take more work, but they can think creatively and they will do something better in a different direction. They will be given that kind of education. So this flexibility can be introduced. And further, the modularity helps in the grading process. So because every module can be given certain points, and these points can encourage them because they get intermediate accomplishments, and you can say partial credits for partial success. And if you do a continuous track without having modularity, then grading is actually going to be very hard and very complicated. So here grading is actually beneficial. In fact, the most recent course that I have done, I have one track 2. If you see the modularity within the track 2, I have given a draft version 1.0 submission. Okay, and then I have also asked a draft version 2.0 submission, and then I have given final submission. Okay, so you can see there are 3 stages in that. In fact, there is one version that's called a topic submission. So if you see the 4 major stages of evaluation, each stage is having certain points. Maybe for this it's 1 mark, for this is like a 3 mark, for this is 5 mark, and maybe for this 10 mark. So by having these marks at intermediate stages, they are bound to do better in the next modules. And this helps me as well as the students. It helps me in the grading. It helps students to make sure that the next goal or next module is well done. So there can be synchronous modules or asynchronous modules. So what do you mean by synchronous module? A synchronous module is like a module of one track may depend on another module. Then it is synchronous. Or if it is independent of another module, then it is asynchronous. So let's look at this particular example. This is actually track 1 with lectures and track 2 prototype building, and track 3 is the documentation. Okay, many times that's what I'm saying. Documentation is very critical. You as a teacher or as a research mentor, you have difficulty if students document their activity. So if you define as a track, then they realize and they try to deliver the modules. Okay, now but you cannot actually have certain modules in one track started before the other track. For example, modules in other track. For example, in track 2 prototype building, this is a module 1 of that. So I'm asking some level of the prototype building to be ready. And track 3 is a documentation track. And this documentation tracks T3 M1 depends on T2 M1. Only if completion of the document building that I can actually ask this. So this is actually dependent on the activities conducted here. Okay, and same with the track 2 M2, that is influencing the beginning of track 3 M2 too. So that way these 2 tracks have modules which are synchronized. Okay, whereas this track may be independent or dependent or synchronized or asynchronous. That is possible. So this is an example here. So you have track 1 lectures here and small GIS experiments is track 2. Okay, these experiments may be dependent. After covering some lectures, you actually have this is a T1 M1. And T2 M1 depends on T1 M1. Okay, then it is synchronized. And again, you have T2 M2, which is actually depending on some learning that is to be done on M3 of T1. Okay, M3 of T1. So that way there is a synchrony here. And if you see here, this is actually not necessarily synchronized because the track 3 here is data set or literature review. So this is not really connected with these experiments that you carry out in track 2 M2. Okay, this may be doing in parallel. In fact, if you say a capstone project, which can be another activity where a major project has to be delivered in various modules, M1, M2, and so on to M final for the track 4. That may be starting along with the course without having any synchronicity. So it's possible that some modules may have synchronous requirement, some modules may not have synchronous requirement. The instructor's choice of the topics, nature of the subject, and definition of tracks will decide whether there is a synchronicity required or not. So there are so many possibilities of tracks. If you see as an example of IIST combination geoinformatics, you can ask them to do open source software development, which will help them to build some modules of or some software collectively by the class, or LIDAR software development, track on temporal flood map variation over the years. Each student can focus a certain area, geographical area where he creates a map for that. So you will collect overall the entire class a certain state or the country. So analysis of water body depletion or sea erosion critical. So these are actually some of the example tracks on geoinformatics if you take that as a subject. But if you take any subject, computer science, ECE, or electrical engineering, we will be able to find several tracks. For example, deep learning activity. You may be teaching deep learning in 1 or 2 subjects, but you can ask them to focus on certain aspects of deep learning, either by conducting survey or defining a track for projects or whatever. So they will have much better skills on deep learning than what the lectures alone can provide. Okay, so in fact, data analysis and trajectory prediction on certain locust. Locust is actually a small cricket-like creature that creates enormous amount of losses when they affect an area. So you can give different types of activity tracks as you demand, as you really want the students to develop advanced data structure and development track and so on. Now, if you look at another example course, this is again an interdisciplinary course of biomedical engineering between electrical engineering, computer science, biology, and so on. So you can define tracks, activity tracks, a hospital visit track. So a biomedical engineering student who had not visited as a volunteer to a hospital is actually not really learning the ground reality of healthcare. So that way you can create a hospital visit track. Maybe students will visit certain hours of hospital or volunteer for certain hours in a hospital. That's actually going to add a significant value to the classroom because they now get a passion for the area. Or even in a hospital, in several hospitals, you have this particular real problem in Indian hospitals, like medical colleges. So the patient, there is no flow of patients. Because the entire walkway, entire corridor, entire area is filled with the patients. There is no flow of patients. Usually in all Western hospitals, patients flow from the entrance to the treatment rooms to the, the inpatient area to the exit or whatever, depending on how outpatient or inpatients behave. But a study of that actually is very important for designing large hospitals. Okay, so how is the real situation in very populated hospitals? So that study can be taken up by students as an activity. Community surveys, patient experience survey, or technical writing tracks, research projects tracks. In fact, these two tracks are actually very important tracks for every area, particularly CS, EE, ACE, and so on for students like a PG and PhD students. So it's very, very important. If you have these tracks, that can make a very big difference. But even development of devices in the biomedical course, it can be biomedical device or reverse engineering devices. So this is actually very important complementary track that you get a device and ask them to break open. Okay, when you open up any device, you as a teacher will learn a lot of new ideas. And students will think that the teacher is actually excellent teacher because students are also learning many new things. Okay, so reverse engineering devices will help uncover the design, engineering, system aspects of any device. Okay, usually teachers will not do this, but it's a very, very attractive thing to do in a classroom. Okay, but before going into the classroom with a device, I will advise you to do once before and get yourself familiarized with what you may be understanding from the device before stepping into the class. So any kind of survey, these surveys are very important for update of the subject by the students, by the teachers, by the administration of the institute too. So new biomaterials study track, which may not be taught in a classroom as part of the syllabus, but track can be created. So students will be really getting some new learning in this direction. Prototype development for Internet of Medical Things, video tracks. Video tracks, again, I'm saying this is a very important track to complement what you teach, especially on biomedical engineering. Okay, so in fact, all medical education is transformed by the video experiments conducted by several hospitals. Today, doctors do not teach just using the blackboard, whiteboard, and computer PowerPoint presentations. They actually demonstrate how other people have recorded conducting operations or recorded conducting the patient situations. And that complementary track is actually going to make a big impact in your class for your students in a very, very significant way. So for UG courses, okay, UG courses that you are involved with or your university is involved with or you are creating curriculum, I would recommend for semesters S1 to S4, integrated multi-track multimodal teaching, IMT. Okay, so this is actually going to give better basic understanding of the subjects. Okay, because they are actually not focusing very well. For example, basic electrical engineering. Okay, this is a fundamental course, basic electronics engineering. Okay, this is also fundamental course. So they are actually not going to learn very deep into very subject level at this point. So intermediate IMT is actually very good. For S5 to S8, multi-track modular teaching, MT2 is actually better. So if you, for example, if you try to do some track, say T2 to TN here, okay, or S6 T2 to TN here, okay, that performance can be visible here. So this here, you will be able to see the performance when they do the project. You will actually get an expertise. So depending on how you define the tracks here in the later semesters, you will see the students' performance in the project will be much better. Okay. Now, so for the PG students, for MTech students, MS students, and so on, assuming there are 4 semesters, I do not know there will be 4 semesters hereafter. It can be even shorter in the future. But if we do MT2 in semester 1 as well as semester 2, that will actually very good. Because if you do say track 2 on writing, okay, track 3 on whatever other tracks that you want to learn, depending on the MTech program, okay, depending on the MTech program and the course that you handle, then this investment of tracks will actually be rewarded by the outcome of the project. The project performance will be much better if you actually introduce them these tracks for activity. So, for example, many academic institutions projects are like 1 semester full or both semesters full. They do industry or academic project. Okay, but you can honestly evaluate the MTech reports of several universities in India. Okay, and you will find the performance or the quality of the reports is not up to the level that you really want them to produce. Okay, except in very small number of institutions. Out of, if you take top 100 universities, even if their NAR ranking is very good, in fact top 50 or so, you will be able to find the number of quality MTech projects reports will be very less. So I must say, if you introduce a mandatory writing track in your courses, in your technical courses, to create them to have writing as part of the course on the topic of your course, you will see performance improvement in the outcome. So today, these reports are actually intellectual properties. Okay, these reports are actually not only published some cases in some universities, this is purchased by others. In some universities, this is actually made available publicly. So a good report is very important, and for them to produce a good report, they have to produce good technical work and good writing too. Okay, that has to have a specific training. Otherwise, they are not going to pick up the trick, pick up that trick. So multi-track approach will help them to develop the skill in these directions. That is very well rewarded at a later point. So that's the reason I'm saying planting these useful seeds within the courses must be done, so you will reap the rewards. In fact, for all PhD courses, I would recommend multi-tracking. If you are the advisor, okay, if you are the advisor, you have to have the necessary detail. In fact, the various tracks you should define from T to T2 to TN, so that you will get the necessary skills for your student in your research. In fact, when I do PhD student courses, I will ask them to specifically deliver the research experiments, simulation experiments, or analysis experiments, or writing a task in multiple directions during the course. So subsequently, they will benefit in their later research. So this is again planting useful capability seeds early in the PhD course, so they will not struggle. Now, if you don't do this at the 3rd year or 4th year of PhD, they will actually become very poor in the real activities where you need the student to do excel work. Okay, so that's the reason I said. So tracks in the research area should be defined. Okay, you are asking the student to do data analysis work. You can define track specifically in that research directions. Okay. For example, if you are devising an IoT for security, okay, you don't just teach them IoT security. You don't have don't allow them to just take a course on cyber security or IoT device security and so on. You give them tasks as part of the tracks in the research area. These tasks may be very, very small tasks, but these tasks planted early in the PhD coursework will benefit you in big rewards here. No, in later research. Okay. Similarly, the writing, when you find the student is struggling for writing the thesis or writing a research paper, in fact, the quality of research paper is actually another very important matter, and you can do this multi-track approach to improve the writing by introducing the tracks in your research, in your teaching course. So later they will be doing better writing too. So that way you will use this research-oriented teaching by having appropriate tracks. So how do you do in deemed universities and autonomous colleges? So you can identify the courses where research-oriented teaching is essential. So you are the best people to judge. So you can judge, this area, I want to do research. So the course I am teaching in that area should be following the multi-track approach. So you can design activities where you want the student to acquire skills. You can also assign credits for that. Track names need not be finalized, only credits can be identified, because tracks you may want to experiment over the next several years with the different types of tracks that might be benefiting you over the years. Maybe first year you have designed for machine learning tracks. Next year you want to try that machine learning and deep learning. The third year you may want to see binary deep learning or whatever. So you can actually design the exact activity for each track when you actually offer the course. So this is where the teacher gets a flexibility. Okay, in best universities, teachers have very high flexibility. In not so good universities, teachers have very limited flexibility, and in very poor universities, teachers have no flexibility. Okay, so if you again draw this particular the pyramid of teachers, the highest level universities, high flexibility for teachers. Okay, in deciding the curriculum and in executing the curriculum and in modifying the curriculum and so on. And the bottom of the pyramid has no flexibility in the curriculum. So India is actually moving from this no flexibility to better flexibility over the years. In fact, deemed universities stand somewhere here on the pyramid. Now, so you can decide on what kind of credits you want to give. You want to give lecture credit 3, activity credits 1, or you want to give lecture credits 2, activity credits 2, and so on. So it's somewhat similar to the lab credits that we introduce in some of the courses. So some universities have a lab credit, but in the lab, they do not actually focus on a specific area of skill. In a track, you are actually defining a specific area of skill and you are designing the modules for that, which can directly be benefiting your R&D project. So that way, the university benefits, the teacher benefits, and students bring or develop a certain very important practical skills. So curriculum design can introduce certain MT2 credits that the teacher can actually use for flexible teaching. So some of the benefits in description. MT2 formalizes a structure for multi-modal teaching such that teachers in India can enhance the quality of teaching, enhance students' engagement in subject, deeper and better understanding of the subjects, enhance students' confidence, removal of students' fear factor. When students do such multiple activities, their fear of the subject and fear of the teacher will also be reduced, and thereby improving the employability of students. And teachers expertise is very important. Teachers are supposed to be experts in the subject to use MT2. But in case if you have limited expertise in a subject that you teach, practicing MT2, will make the teachers expert. Okay, because this is actually a dual use thing that the practice will make the teachers improve as well as students improve, because because teachers also experience the multimodal learning when they teach the course. They will learn faster when you do teaching. So I have done some simple no, studies over several courses. I don't show much of result in 5 minutes. I'll just briefly before concluding. So this is actually a paper that we I published in SIGCOM education workshop in 2020. So I have taken some survey of perceived effectiveness of online classes compared to physical classroom sessions. Okay, online versus physical. Okay, so online versus physical. So what way students they think for courses. Okay, so I asked them, do they get the same benefit in online classes versus physical class? And students have given me this feedback. Okay, and 39%, which is a significant fraction of the class who responded, say that they get half the uh, effect. Okay, half the physical classroom experience through online classes. Okay, and the rest 25%. This is actually the best, the biggest fraction. 25% is say that they get only a quarter of the. They get only a quarter. Okay, so which means more than 55%, more than 55%, or more than not 55, like about 60% have only partial benefit. In fact, so there is about 1/5 of the students, they say 75% is actually get. In fact, if you take this number, 60-70% do not find that online classes are as effective as physical classes. I also conducted a survey for how this MT2 based computer networks course performed in comparison to other courses where MT2 is not followed. Okay, this is again part of a survey conducted. So I asked 90% of more. This is with respect to online classes where MT2 is used and not used. So I found students who reported 90% of more of the physical classroom were 8.1%. Whereas when I used MT2, I got only 7.1%, confirming that they got 90% or more. Okay. So when you consider the students community where 75% or more of the physical classroom effect was obtained through online classes, for general courses without MT2, I got only 19.8% students agreeing, but we have got about 21% or more students responding that MT2 actually helped better in learning online thing. Okay. Similarly, among those students who have benefited only 50% of the physical class in a lecture online class, in general, 38% students responded yes, but for MT2 class, 39.3%. So if you see that similarly, among the middle top tier, entire middle section, say 25% and above and 50% and above or 75% and above, we have significant improvement obtained. So this is like, 7 plus 1 point something and 2 point something. So about 10% improvement in online class, online plus MT2. Okay, online is not effective as much as a physical class compared to not having MT2. So MT2 in online education also is actually effective compared to physical. In physical education, physical classes, this is much better because you can do experiments, you can do a lot of physical activities, which is not possible in online domain. Online domain has a lot of issues, but having MT2 added to online element, you actually can improve the effectiveness of class at least by this percentage, as I have observed in our own survey. So let me just close this by concluding that. So integrated multimodal teaching is very useful for basic courses, first year courses, or courses where depth is not very essential, where you handle broad topics or even language courses, and This is still one of the very important method of multimodal approach. MT2 is relevant for advanced courses, senior year, UG courses or PG or PhD courses where course depth is required, or deeper training on selected topics is very essential. Or when you are teaching a highly technical course where you want to learn different angles of the same subject, you can actually use MT2. In fact, this is a better example of multimodal approach for research-oriented courses. Okay, so yeah. So let me just summarize. So we have multi-track modular teaching, which can divide a course into multiple parallel tracks, with each track having different set of activity modules. So the activity modules are flexible. You can design. Yes, please.
So can we finish in another 5 minutes, because we are already running off the time?
Actually, I'm finished. I'm in the summary slide. And this
Yes.
the second last slide. The last slide is thank you slide.
Okay, sir. Sorry to interrupt you. Thank you.
No problem. Yeah, I understood. I overshot 5 minutes. Okay, so you can have flexibility in the tracks. Modules can be defined optional or cross. Tracks can be light or harder, and some modules can be challenges too. So teachers are expected to be experts in the subject, and if not, the teacher will actually benefit and develop very fast. So let me, this is actually the certificate that I have received from MHRD in 2016 for developing this particular technique. It's a photograph of the certificate that I received. So let me cross this. These are the two references. So in case if you are interested, you can look at that, this ACM SICOM education workshop paper, and this is actually a book on this topic. Now, yeah, let me just conclude, and if you have any questions, you can ask me now or you can email. Thank you for listening.
Okay, thank you so much, sir, for that insightful talk. I would request all the attendees, if you have any questions, kindly raise your hand and ask your question.
Manoj sir,
Yeah,
I have a query. So
yes,
I will like to know about, is there any difference between designing tracks for a language course and a research-based course? Like, or is it somewhere related to that quadrant-based course design, like UGC has given recently, that quadrant, 4 quadrants? First quadrant about the course material, second about your lectures, whatever you teach. Is it somewhere related to that? Can we?
Yeah, actually, this is about how the material is delivered by the teachers or the students. The material is like the information that you deliver. So first, let me ask the language course related question. So in the language related classes, so it's highly integrated to have an effective class. So the teacher actually describes language, then he actually speaks in the language, or you are actually teaching Hindi using English as a medium. Then one has to actually speak in Hindi and show the examples of speech in Hindi, show the sales, different, many teachers use multimedia to actually do an effective content delivery in that. So that way, multi-tracking is actually not as effective as integrated multimodal teaching. So irrespective of what is your curriculum, we can actually practice this. Okay? And UGC regulations, I don't recollect what exactly is the content delivery method. But if you are a teacher teaching a topic, if your objective is to actually train the student to be useful for certain area, to be capable of doing certain area, you can actually design the activity tracks, which will get you a different level of expertise for the students. So
yes, this I actually for language course I was a bit confused. Now you clarified, because I do remember when I was there for that internship with you at IIST. I do remember in 2018 you were doing some project like this for track based. They were creating the test beds. Another group was doing another things, and then you had a combined session on one Saturday, and we had deliberation on what track did what. So
Right.
for that area, I'm okay, but I was not sure about language thing.
Yeah, language courses in fact all language courses in all universities have teachers developing what is called language labs because they needed a different kind of facility to actually deliver language classes, which is a very good example for the first category I mentioned, IMT. But
Right, sir.
of course, yeah, if you are actually having a writing class, okay, not the language class where they not teaching, you are teaching for language proficiency for speaking. In case of writing class, MD2 actually can be very effective. Okay.
Yes, yes.
Yeah. Similarly, for all engineering subjects, MD2 is very effective. So you will be able to. In fact, if you are a PhD teacher teaching for PhD and guiding students in PhD, you have to target their research skills and the writing skills early on in the coursework itself if you want them to develop better researchers. Okay. So
Right, sir.
that way you can introduce some tracks and activities in the course. So they will be able to have enough time to develop themselves during the course. In fact, it has benefited in case of several students. And similar to PG students is actually the number of PG students in any university is very high, but the research outcome from the PG students is very limited too. So this is like an untapped human potential that is not tapped because the current education system is actually not training them to be useful in creativity or creative directions. So MD2 is actually a very good tool to benefit from that population.
Right, sir. Any other questions? Attendees, any other question?
So
I think,
I
sir,
have
we have no question.
one small
Yes, Garima.
query.
Yes, ma'am.
Like Viva ma'am have already asked regarding the language-based courses. So sir, again, if we have those elementary courses which are mathematical based, so for such kind of courses, what kind of small modules we can include to make the lectures more interesting and engaging?
Yeah, that's a very good question. In fact, I remember a teacher in mathematics who is teaching the BSc students. Okay, mathematics courses are a different kind of courses where they have to derive equations, and sometimes
Right.
students do not get the real perspective of the equations. Okay, and this teacher brought an innovation of using MATLAB to teach mathematics. Okay, if she is actually developing an equation, she will derive the equation very quickly, and then they will switch over to MATLAB and shows how the equation behaves under various cases. And the teacher has limitations on showing all the various extreme cases and the variations of the variables, and as a result, the result equation behaves using MATLAB. So that gives students a big complementary content using MATLAB. So you can use such tools to bring a big difference to the math classes.
Okay. Right. Thank you so much, sir. So I will just conclude this session. It was indeed a very informative session, and thank you so much, Dr. B.S. Manoj, for sharing your valuable time and expertise with us. I hope each one of the participant who here has joined today as a faculty are all geared up for the upcoming semester and would also include those innovative and creative methods that you have asked us, and would surely make the lectures more engaging and more interesting for the students and for our own benefit also.
Yeah,
So
thank
thank you
you.
once again for your gracious presence, sir.